Hey guys, let's talk today about algebraic properties. And I apologize, my video seems a little crooked. I'm going to write with dark markers so that you can hopefully see it. But as always, there will be notes right below this video. All right, that go over everything I talk about. So you can write things down as I go, or you can just open up those notes and kind of go with them. So we're going to look at algebraic properties today. A lot of these are stuff that we just do automatically. We don't think about it, but we're going to, kind of look and see why we can do what we do and the actual names for these things. So we're going to assume that A, B, and C letters, okay, don't get too freaked out, are numbers and that they are real numbers. So anything that we do with them will still be real numbers like we talked about last week. All right, so our first property here is our closure property. And all it says is anything that you do for addition or multiplication with the real numbers, it'll stay a real number. So if you take two real numbers, A and B, and you add them together, it's a real number. I know you guys know that is the hashtag sign. In my day, that was the symbol for number. So that's a number, because I'm too lazy to write it all out. And for multiplication, if you multiply two numbers together and they're two real numbers, then their product is a real number. Remember, a product is the answer when you multiply two things together. So that's your closure property. The next one is a commutative property. Commutative, and this is like our mirror one. So if we take A plus B, that's the same as doing B plus A. Okay, and same for multiplication. If we do A times B, that's the same as B times A. Doesn't matter what order they go in, it'll give you the same answer. Okay. The next one is our associative. And although I know a lot of you are like me and you like to abbreviate things, please be sure to abbreviate associative a different way rather than the first three letters. I don't want to see any of this on your work. Please and thank you. Moving on, all this says is if we have three numbers that we're working with, it doesn't matter how we go about doing them. So if we have A plus B plus C, we can add A plus B first, then add C, and that will be the same as if we add B plus C first, and then add A. Doesn't matter which order you add them in, they're all going to be the same thing. Same for multiplication. Doesn't matter which order you multiply them in, if it's A times B, then times C, or the other way around. It's all going to be equal, because addition and multiplication are two things. It doesn't matter which order, which way, anything that you do them in, it's going to give you the same answer. So that's pretty cool. And again, I know I'm going a little fast. This is a recording, so you can always pause it and go back. You can always pull up the notes that are below here, however you want, and however you need to learn. Plus, if you have questions, just send me a text, and you and I can get on a Zoom meeting. We can do a FaceTime call some other way and go over this stuff more. All right, we have three more. So our identity is whatever we can do to it, that'll make it stay the same. So the only thing we can add to any number for that number to stay the same is 0. Good job, guys. And the only thing that we can multiply by anything and still get the same thing is 1. So anything times 1 is itself, just like anything plus 0 is itself. It's a thing that we do that doesn't change anything. It's kind of funny, it's kind of pointless, but it's a math fact, and we do use it in other senses. So, okay, we have our inverse property, which I'm going to talk about more in just a few minutes. But what it says is if we add the opposite to anything. So like A would be negative A. For example, 3 and negative 3 are inverses of one another because when you add them together, they equal 0. So an additive inverse, which again we'll talk about more in a minute, just means the inverse of something you're adding, will always equal 0. And for multiplication, the inverse or multiplicative inverse, again, we'll talk more in a minute, is anything times its reciprocal, and it will equal just 1, okay? So it might be a little confusing. I'm gonna come back to this in just a minute. Okay. Now, our last property, and you'll see I got rid of it, it's kind of an overarching one, is your distributive property. A lot of you already know this. So if you have something like A times B plus C, what we do is we distribute that A and multiply it into the parentheses, okay? So this would equal A times B plus A times C. That operation there in the middle will stay the same, all right? All right, I hope we're doing okay. Again, if you guys have questions, just reach out to me. Let me know, we can go over it. Okay, so the first thing I want to ask you to do is to identify the property, okay? So say I write 3 plus 9 in parentheses plus 2 equals 3 plus 9 plus 2, because it doesn't matter which order we add in, right? What would you say this property is called? And if you guessed the associative, you're correct. Sometimes you'll see it written as the associative property of addition. That's just a long phrasing for this is the associative property. And I am good with you just saying associative. Don't need to add in all that extra word garbage. Okay, let's do one more. What if I tell you to tell me what property this is? If I give you 14 times 1 equals 14. If you guessed the identity property, you would be correct. This is not the inverse because we got the same thing as we started with rather than getting 1, okay? If our answer is ever 1 or 0, then it's the inverse property. If the answer is what we started with, it's the identity property. Okay. All right, so you know that thing I said we were going to come back to? Please excuse my cat as he interrupts the lesson. He does that. Come on, Tula. Some terminology to talk about real quick. Tula, come on. The first is opposite or additive inverse. God, cat. And I am so not re-recording this whole lesson just because he walked through the screen. So sorry about that, guys. All right, so the opposite or additive inverse of something. Is always the negative version of itself. So for example, if you have 4, the opposite or additive inverse would be negative 4. What if you start with a number that's already negative, like negative 2? The additive inverse would be negative, negative 2. And we know that 2 negatives always make a positive. So the additive inverse here would just be positive 2. All right. All right, Tula, say bye to everybody. Bye-bye. I'm going to go somewhere else. He's a stinker. All right, last thing, guys, is reciprocal. Or this is sometimes called the multiplicative inverse. Again, I have all of these notes already written out for you guys right below this video, okay? You can open it up, save it to your computer. If you have a printer and you want to, you can print it, do whatever you guys want, okay? A reciprocal is when we take a number, such as 3, and we flip it under the fraction bar. So it goes underneath the number 1. So 3, the reciprocal would be 1 over 3. Okay. Now, what if you already have a fraction? All right, this is a funny one. Say you have 3/4. All you do is you flip the numerator and the denominator, and boom, 4/3. That's the reciprocal. All right. So if you guys have any questions, reach out to me. Let me know. We can do some FaceTime. We can just kind of answer questions over text if you need to. All right. Good luck, guys. Now you can try the work right next to this screen.